Student. Audible and visible both. Basically, my screen is visible. Thank you. Good afternoon, all. Good afternoon to all. What the students are present in this group? Only 2 students. Earlier, 1-2 students. They respond. Good afternoon to all. Yes. So you are in now presently you are in second year, no? You are in second year student, section B. Sure, sure. Are you sure you are third year student or second year? How many are confident about that we are basically third year student, not second year? Tell me. Again, I get only 2 response that yes. Pardon? So the class belongs to for the second year student or third year student. So that's my I asking you question that you are the second year student or third year student. If you are third year, so forget about the story, whatever you done in the second year. So third year student means you are more responsible, you are more disciplined. So you know, in next year, in this time, you are sitting for placement. Do you have any idea? So placement already started for fourth year student. Do you know these things? Tell me, guys. Please respond. Yes. So that means we want the student, those are belongs to third year, they are more disciplined, they are more confident about he or herself, him or herself, more attentive, you are more attentive. So these are the major characteristics is required because you are now third year, you are not in the second year student. This is very much unfortunate. Now this time is your class will start at 1:10, but now this is 1:15. Still, students are coming to join here. This is very much unfortunate for us. So whatever your attendance, whatever your behavior, depend on that. You are seat for the placement. You are seat for the placement. If you are not punctual, if you are not disciplined, you are not obedient, you are not attentive, then I just tell you simple thing. Forget about on-campus placement. You just forget about on-campus placement. Basis of your character, I will share the feedback for your batch, especially individually like section A and section B, sent to placement cell also. Please, you Those people are attending my class. Thank you for that. But those are not attending. So 50% student only present in this group. So those are not attending. Please tell them that please attend the class. Otherwise, they have faced the problem. You are in autonomous board. If I'm not wrong, please tell me. Anyone, please respond. You are in autonomous board, no? So everything under our jurisdiction. What I am express here, you understand hopefully. We want, we can divert from your semester exam, mid-sem exam, or in time of the placement also. So be please attentive, more discipline, and we require more punctual. If anyone having class starting from whatever, as example 110, you must enter the class within 15 to 110, in between 15 to 110. So next day onward, I will not tolerate. Next week onwards, I will not tolerate. Clear? Please respond. Clear? My voice is clear? Thank you. So in this time, I will take two subjects, partly, obviously partly. So one that found that is concept of digital signal processing, that means DSP subject. Another subject I will take, that is the computer architecture and organization. So I have already taken two classes related with the DSP for section A. I have already taken. So that's why today actually your class is the computer architecture, but this time I have taken your DSP, and end of this week I have another DSP class. I also taken this class also. So the both the things is parallel. Clear? So DSP subject, yes, share with Moloy sir, Atunu sir, and me. And you already familiar with the lab. I will present probably Friday lab. And another thing, 3 faculty are associated with your computer architecture and organization. So in this computer architecture, in the last semester, I was taking microprocessor or microcontroller. Your subject name is microcontroller. So most of the thing I already share with you. Most of the thing I already share with you. Till we can repeat here some of the part, and some new concept also we will discuss over here also. So let's start with the concept of digital signal processing. So you are knowing about my name, so I'm just sharing the PPT directly. So 3 terms are associated with this subject, digital signal processing. So what about today topic we will try to cover? First thing, we are talking about the understanding between D, S, and P. We discuss here signal with analog, discrete time, and digital, and why digital is paper. So this is the basic part. today, the introduction part, today I will discuss. I hope everyone knows this 3 point understanding between DSP signal with the analog, discrete time, digital, and why digital is favored. You know, but till now we just first introduce the subject. So before we start, the interesting part I already mentioned, in the name of the subject is digital signal processing. Digital signal processing. So first we discuss about the signal. Signal is the variation of physical parameters. Are you agree with me, guys? I gave some definition. This is very simple, relevant with your subject. If I say that signal, I'm not talking about the electrical or mechanical, whatever. I'm talking about the signal. The signal is a variation in physical parameters. Are you agree with me? Yes or no? Please respond. If you are not responding, that means you are not attentive. So please respond. Quick response. So, okay. Thank you. So, anyone guess the fit? Yeah. Yeah, this is we can say the signal as per the definition. So you can express different way. But here, what I am representing, that signal is a variation. This is variation, obviously, variation of physical parameters. So I agree with you, Rasdeep. Thank you. Anyone guess what type of physical parameters here I am talking? Anyone? Okay. Or anything? You are belongs to DSP, so you just think yourself because you know the prerequisite subject, signal and system. You know already digital electronics. You already know the microprocessor. So these are the prerequisite subject for DSP. So you know the definition or something example. Anything else about the physical? Parameters, physical parameters. I mean to say the physical parameters. Lastly, probably say that time or something. Physical parameters. Like example. I want the example. Anything? Frequency, amplitude, anything? Okay. Let's see. I give you some example. What about these physical parameters? There, I am considering three major physical parameters. Anyone guess what is that? What about this device name? Thermometer, simple, exactly temperature is a physical parameters. Let's see. Temperature variation. If the temperature is not varying, can we say this is signal? So you are using the thermometer, everyone having the thermometer, isn't it? So if it will be taken inside the boiled, or maybe boiled is too hot, is checking the temperature of water. If there is a no variation, what we are telling, so this device is faulty? Yes or no? So that means there is a no variation. So temperature variation we are considering there. Anyone guess what about that? Lecture. So physical class is already, it's not going on. So we can say speech as I speak. So this is basically the, what is that? Voice modulation? Yes or no? Anyone guess this one? This one is, anyone guess? Good. This is considering one supported television. Now tell me, what physical parameter here I am rated? No? Physical parameter, what type of parameters? Physical parameters, there I am talking. Anything, anything? Repeat. Okay, any other point? What type of variation we have found in television? If that variation is not present, that time we say that this device is faulty. Exactly. Good. Video, we can say in television we see the video. So video is as basic, obviously sound, but major part is the video. No, obviously when we are talking about television, we already voice already mentioned in the second point. So that's why I'm talking about the light intensity, variation of the light intensity in intensity. Now we are in electronics engineering domain. So, so what about the definition of signal I proposed? Signal is a variation of physical parameters. Yes. So can you modify it in term of electrical engineering domain? What about the definition of signal? Signal is a variation of physical parameters. You already agree with me? Yes. Now we are talking about electronics. We are now presently we are present in the electronics engineering domain. So now can you modify this definition? Can you modify this definition? That definition, whatever we earlier discussed. Any other person? Okay. Ranjal most probably says that voltage. Aditya says that current. Any other person? Anything to say? Please repeat. Power. Okay, let's see. Signal is a variation of electrical quantity specified here. Electrical quantity as a voltage or current in a function of time. Now you are happy, guys. about the definition of signal? So you have already mentioned, so someone they found the name. So here voltage are there, current are there, function of time is there, electrical quantity is there, variation is there. Now you are agree. So now, can you give some example of the electronic signal? Can you give some example, application related example of electronics signal, or rather electronic signal? Can you give some example? Telephone. Okay, let's see. Here I will mention the first point, that is motion. Okay, I just interrupt one thing to tell you that I already shared the exam code in your group, class group. The time duration I also mentioned over there. The logging period. Logging period is probably 1 to 2. So please, in between the class, you give your attendance. We have checked CRP attendance very carefully, and also those people are present over there. So there is a software present in Google, extension is present. So through the extension, we also download those people are present over there after the completing your class. So then we vary, and after that we verify that those are not present but give the exam. We may take action. We may take the action. So be careful about your exam. So you give the exam. And another thing I just tell you, please improve your hardware. That means if you are using computer, laptop, desktop or laptop, please improve your desktop or laptop, and also improve your broadband connection, improve your connectivity. Now this is the stage. If you thought we are manage the class through the hotspot, through the mobile data, this is not the right choice. So please improve your connectivity and also improve your hardware. Also improve your hardware. Some of the students, they basically, when they give the exam in the placement, like 3 exam already done. One is the Cognizant Digital Nurture, another is PCS Digital, and another is a Infosys Digital Role. So these are the higher package, like 8 lakhs, 5 lakhs, 6 lakhs package. 10% student are there, they not upgrade their hardware and their connectivity. So we always recommended Wi-Fi. We are not recommended Wi-Fi connection. We always recommended the wire connection. So please, you have a 1 year time from now onwards approximately. So please improve your internet connectivity. Otherwise, you have been faced lot of problem time of the placement. If you have doubt, sir, क्या बोल रहा है ये झूठ बोल रहा है आप. If you want, you can also verify with your senior also. Some of the students they can manage, but we always recommend it, because if you have faced the problem, so now everything is AI enabled software. Whatever you give your exam in online, that software is AI enabled. They can check about your detailing of the specification. Also, they check your hardware. Also, they check the internet connectivity. Everything they check, isn't it? So I'm requesting you for folded hand. Please improve your internet connectivity as well as your hardware. Clear? So let's continue. So please give your exam. Already I give you the time for giving your exam. So please give your exam first. So now we are talking about the motion. Motion of an object can be considered to be a signal. Radar can provide an electromagnetic signal to follow the aircraft motion. So you already know this example. Another example we are considering, and we also found in the last slide also, that is a sound. Sound is the variation of medium as air. Then we are talking about the image. You also familiar with the image, a picture or image variation in brightness or color. Someone is already mentioned this point. Intensity, signal. Then video. A video signal is sequence of images. So lot of example are there about the electronics engineering domain signal. Now we are talking about, already mentioned about the basic thing of the signal, various types of application. Now we are talking about the majorly the signal types. So two axis, this is two-dimensional figure that having a two axis. One is the x, another is the y, and naturally we are considering x-axis as a t and the y-axis is the amplitude, we can say, and this is the function of t. So a signal can take any value within a given limit. You just remember this point. A signal can take any value within given limit and it varies continuously. It's a depend. It varies continuously. Always varies continuously in different instant. Maybe the different instant. Suppose this is the signal. I can show you a graph. This is time. Suppose this is your voltage. Can we say this is signal? Tell me, guys, is this signal? There is, because they vary from what I am telling. The signal can take any value within the given limit. What about this limit? Suppose, for example, this is 0, and this point we can say V max, sorry, V max, and this is 0. Obviously, this is also signal. So someone having a doubt, so that's why I'm just clear here. So I already mentioned that the minimum value 0, or we can say V min, and maximum value of V max, and the signal always varies within in this range, within this range. Now we are going to know about the signal. So variation of the signal, which can take any instant of time, it can take any value between those two limits. Such type of signal we call what? Such type of signal we call bias. You are not responding. I am audible. Student, please respond. I say that this is analog signal. Okay? So the variation of signal which can take any instant of time, it can take any value between those limit, it's called analog signal. There is a note I given the detail of the definition. Now we are moving to in different things. So please guys observe here. So initial case we are written T. In place of T, what we are written? What we are written? A. What is that? Anyone guess? N means what about the name of this N? Because you already attend 1 lakh class. You already attend 2 lakh class most probably. So in its name is having a specific name. Anyone guess? Anyone? No. Some name is. No, what I'm telling, T equals to what? Time. What about N? We called. No. Whatever variable, all are variable we have to consider. Name, the name of the variable. Number of sample, no. More closer. Try again. You have already having a 2. You already performed the 2 lakh class, no? Let's see. This is very unfortunate. So we are considering N0, N1, N2, N3, N4, N5, N6, N7, 8, 9, 10 up to N, isn't it? So process the signal only at discrete instant of time. Obviously, someone is already mentioned, sir, this is a discrete signal. I am agree. But some term required to know. So anyone guess what about this one? No? Already someone mentioned this line name. Yeah, it's a very simple. Sample I written. What about this one? What about this one? Yes. Loop means flow. Okay. Yeah. Yes. Name had a key. What is that? Okay. So before that, I am asking another question. So what about this one? This variation depend on what? If your signal is sinusoidal, your signal is sinusoidal, so what about how we get this part? What is that? This is basically what? Very near. Try. No. The curve. This is. Yes. My God. This is the basic introductory class. So very much unfortunate, you forget about everything. You don't have the confidence we require, guys. Confident, otherwise you have faced the problem in time of the placement, guys. You know, one of my student in the third year, when he are in present in the third year, it's not third year, it's probably second year. He attend one competition which basically conducted by Sankal Semiconductor, and he got a job offer also. See, having a lot of confidence. So we require the confidence, guys. So this is simple frequency and written here also. This is frequency. Now you are everyone agree with this, that this is frequency? Yes or no? Okay. Now you tell me. Just a second. What about this one? What about this one we called? Tell me. You just try, guys, please. Tell me. Absolutely in between the sample, whatever are present, that is sample frequency. বেশি কথা বলতে হচ্ছে না, বিকজ আমার ফিভার আছে, ঠিক আছে, কলেজে এসে গেছি বলে সেই জন্য তোদের ক্লাস নিচ্ছি। সো বেশি আমাকে কথা বলাস না, একটুখানি তাড়াতাড়ি অ্যানসার দে। I request you guys, I have a fever. This is exactly your sampling frequency. Yeah, anyone having any doubt? And in MATLAB, this sampling frequency we are considering normally 1 hertz. And if you apply a frequency, that means this frequency is the signal frequency. So this is the signal frequency, another is the sampling frequency. Signal frequency is 0.02 hertz. If you take and drop, you get a perfect sine wave or cos wave, whatever. You get perfect sine wave. If we set the value signal frequency 0.02 and sampling frequency 1 hertz. Clear? And obviously, you also mentioned the sample. So let's talk about this one. What about the name of this one? Anyone now guess? If you're attending the lab class, you know the thought. Tell me guys. No? This is time index. Have you heard, guys? Tell me honestly, have you heard? It's very simple. So don't forget. Whenever you learn, whenever you practice from my part, from my syllabus, whatever I take it. So these 2-3 things you must remember: sampling frequency, signal frequency, sample, time index. Now let's see. So I just erase the So now I just give you some example whenever we consider. So first one, okay. So if we consider like a temperature monitoring process, if we consider as a temperature monitoring process, so every minute instant of time we can take, or maybe we can take every hour, or we can take every day, like, you know, weather forecasting. That part is, we are monitor the temperature every day instant of time. So I just a second, I just erase this part, otherwise. So the value of signal Bn and instant of time, which it's called basically time index N0, N1, N2, N3, as you want or we want, or as long as we are interested in the parameters. That type of signal called discrete time signal. Any doubt up to this, guys? Please. I want 2-3 response, please. Guys. Thank you. Thank you. My God, this is another type of signal. Anyone guess? This type of signal is called? Try any other people? Obviously sample, but what type of signal? This is, anyone guess? Any other person? Any other person response? This is like a continuous. This is discretized in time. Is it discretized in both? No. In the x-axis and y-axis, both we are discretized. Yes or no? Yes, guys. It is very simple. Everyone knows in the last semester, we are talking about the digital signal. Digital signal is a discretize the amplitude part. Discretize the amplitude part also. So discretize the time index or time and amplitude part also. So we are discretizing both the time and the amplitude, and new type of signal we found, and that signal is called digital signal. Is this okay? So hopefully up to this, do you have any doubt up to analog signal, signal definition, analog signal, then discrete signal, then digital signal? Do you have any doubt? Great. Now we found, you can see here, analog signal is always natural, you know, and digital signal is the man-made. This is some example we are considering here. And the advantage part of the digital signal, I already mentioned this part, we can use as we want. We are mentioned this part in discrete signal, discrete time signal, that time we mentioned. And obviously for the digital signal, is also we can use as we want. We can use as we want. If we neglect the some part of the amplitude, it depends on you guys only. Now, this is a very popular example that why digital. So in microprocessor class, I discussed why digital, because this is sophisticated in a small size. It's flexible, low cost, and low power. And we also found some of the part that is the signal processing. This is a processing part. This is example like a recording part is there. So microphone is there, and there is a chip. You remember? And previous in the microprocessor class, I discussed in the introduction part, when we are taking the introduction part, that time we tell that the processor block, and there is a associate some block are also present. You remember? So this is input. You remember after the process, this is output. And what about this associated circuit? I mentioned that sensor. Microphone is one type of sensor. Then what I am telling, A to D converter. So this is A to D converter. And after digitalized, that data will move to your DSP processor. Maybe that voice having a noise, so they cancel through the DSP processor, cancel this noise and then modify the voice. And there is another part is there after processing, D to A converter, D to A converter. This is D to A converter. And for playback, we have the speaker. We have the speaker. So in microprocessor, we call display unit. And there is another option also present. There is a memory part is there, where basically whatever they process through the processor, they can also store. They can also store if whenever we want, we can play the music or something if we record some music. So thank you guys. So now we are discussing the syllabus, whatever we are discussed, whatever we taken in this semester for DSP. That discrete for mainly I am taking the discrete Fourier transform, and from this part you have got around 30 to 40% mathematical problem. You have it 30 to 40% mathematical problems. Okay. So whatever we discuss in your class, that will be reflected in time of the exam. So please guys, please attend my class, because in this semester I'm so busy with me and Unobo sir both. So busy with the placement. So whenever I'm taking the class, please attend. Okay. And we discussed the basis on the syllabus concept of, we have a 1 minute only, concept of the relation for DFT, IDFT, then Quidel factor and their properties, computational burden on the direct DFT. So that's why we are applying linear transformation. So we are discussed DFT, IDFT matrix, then computational of the DFT, IDFT by matrix method, multiplication method, DFT, IDFT method, graphical method, and matrix method. This is basically for associate with the multiplication of 2 DFT. That means we call. So you are familiar with one term, linear convolution. So here we are seeing the circular convolution. Linear filtering using DFT, analyzing error. We are filtering of the long data sequences, how to perform. That time we use 2 major method, that is overlap save and overlap add method. And we done here in the class lot of example and exercise. So I personally recommended the book, that is the Procus we called. This book is available in your library, and you can take also these books. Ramesh Babu is most popular books. And for their syllabus, they are in syllabus, they are having a DSP part also. I am taken also DSP part, processor part, and this is associated with some FPGA. So this part will taken from 2 other books. So thank you guys for attending. Thank you very much. Obviously is need in this semester, coming semester. Isn't it? It's mandatory.